I'm looking at scikit-learn's _check_scoring function, a tool we use to make sure our scoring metrics are valid in machine learning classification problems. It's like a quality control check for our scoring methods before we use them. We're going to evaluate several statements about how _check_scoring behaves. We'll examine if these statements about the function are accurate or not. This statement says _check_scoring gives us a function we can use right away in other scikit-learn parts that evaluate our models, like _cross_val_score . Think of it as giving you a ready-to-use tool after checking its quality. This statement suggests that _check_scoring only accepts scoring metrics from scikit-learn's built-in metrics module. We'll investigate if this limitation is true or if it's more versatile. This statement says that if you give _check_scoring a scoring metric that doesn't exist, it will tell you with a value error message. It's like the function has a built-in error checking system. This statement is saying _check_scoring automatically handles problems where a model predicts multiple things at once. We'll see if this automatic handling is a feature of _check_scoring . I see, the _check_scoring function takes a scoring metric as input. This metric can be given as a string, like accuracy, or as a custom function that you've defined yourself. This is simply the name of the function we are discussing. The output of this function is either a callable scorer, a function ready for model evaluation, or a value error indicating that the input metric was invalid. I'm discussing the scikit-learn library's _check_scoring function. It's a tool we use to make sure the scoring metric we've chosen for a machine learning model is valid and ready to use. This statement is false. I can use _check_scoring with custom-built scoring functions, not just the ones that come pre-built in scikit-learn's metrics module. So it's more flexible than the statement claims. This is also incorrect. _check_scoring won't automatically handle problems with multiple outputs. I need to explicitly tell it how to deal with those multiple outputs by choosing the right multi-output scoring strategy. Think of it like this: it needs specific instructions for multiple tasks. That's correct. If I give _check_scoring a scoring metric name that doesn't exist, it'll raise a value error to let me know there's a problem. It's a helpful error message to catch mistakes early. Absolutely. The main job of _check_scoring is to give me back a function, a callable scorer, that I can easily use with other scikit-learn tools, like _cross_val_score for evaluating my model's performance. It's like a helper function that makes things easier. This is the main question for this quiz. It challenges me to identify which statements accurately describe the behavior of _check_scoring . I'm going to explain scikit-learn's _check_scoring function. It's a tool that helps you make sure you're using a valid scoring metric in your machine learning project. Think of it as a quality control checker for your scoring method. This is the question we need to answer. We'll evaluate each statement to see if it accurately describes how _check_scoring works. This statement is true. If you give _check_scoring a scoring metric that doesn't exist, it will let you know by throwing a value error . It's like saying, hey, that's not a valid scoring method. This is false. I can use _check_scoring with my own custom scoring functions, as long as they're formatted correctly. It's not limited to just the built-in scikit-learn metrics. This statement is also true. The main job of _check_scoring is to give you a function that you can use in other scikit-learn functions like _cross_val_score for evaluating models. It prepares the scoring metric for use. This is false. I need to be explicit when dealing with multi-output problems. _check_scoring won't automatically handle them. I need to tell it how to deal with multiple outputs using a specific approach. I'm going to explain the _check_scoring function in scikit-learn. It's a tool we use to make sure the scoring metric we're using for a classification problem is valid and correctly formatted. Think of it as a quality control check for your scoring methods before you use them in model evaluation. It ensures that the function you provide is acceptable to be used in other scikit-learn tools. This question tests your knowledge of the check_scoring function. We'll evaluate 4 statements about its capabilities and error handling. This statement is true. If you give check_scoring a scoring metric name that doesn't exist, such as accuracy_score incorrect, it will raise a value error to let you know there's a problem. It helps prevent unexpected errors down the line. This statement is false. Check_scoring is not limited to only scikit-learn's built-in metrics. I can handle custom-defined scoring functions as long as they're correctly formatted and callable, meaning I can call or use the function. This is absolutely correct. After check_scoring validates your metric, it gives you back a ready-to-use function that you can plug directly into other scikit-learn functions like cross_val_score for model evaluation. This makes your workflow smoother and more efficient. This statement is false. Check_scoring won't automatically handle problems with multiple outputs. You'll need to explicitly tell it how to deal with multiple outputs using appropriate strategies or custom functions if you have such a problem. Statements A and C are correct. Statements B and D are incorrect. Therefore, the final answer is A and C. Great job. I'll explain what scikit-learn's checkscoring function does. It's a crucial tool in machine learning, specifically for evaluating model performance. I use it to verify that a scoring metric, like accuracy or precision, is valid and to get a consistent, callable function that I can easily integrate into other scikit-learn parts. Think of it as a quality control check for my scoring methods. This is the core quiz question. I need to determine which statements about the checkscoring function are true. This statement says that if I give checkscoring a scoring metric that doesn't exist, it correctly identifies the problem and throws a valuerror error. This is a good way to catch mistakes early. This statement suggests that checkscoring only works with built-in scikit-learn metrics. However, this isn't true. Checkscoring is flexible enough to handle custom functions as long as they are correctly formatted. I can make my own specialized scoring functions and use them without any issues. This means that checkscoring gives me a ready-to-use function that I can plug straight into other scikit-learn evaluation tools, such as cross-validation functions like crossvalscore. This makes my model evaluation process much more efficient and streamlined. This statement claims that checkscoring automatically handles problems with multiple outputs. This is incorrect. I need to specifically handle the multi-output aspect using appropriate techniques. It's not a completely hands-off process for these types of problems. I'm explaining the check_scoring function in scikit-learn, a popular Python library for machine learning. This function is super useful because it helps you verify that the scoring metric you're using is valid and correctly formatted for other scikit-learn functions. Think of it as a quality control check for your scoring method. This question tests your knowledge of the check_scoring function. You need to identify which statements about its behavior and capabilities are true. Let's dive into each statement carefully. This statement is correct. If you give check_scoring a scoring metric that doesn't exist, like accuracy_score incorrect, it'll immediately let you know by raising a value error . This is helpful because it prevents errors later on in your analysis. This is false. Check_scoring is actually quite flexible. It isn't limited to just scikit-learn's built-in metrics. You can use custom scoring functions as long as they're written correctly. This statement is true. Check_scoring gives you a callable scorer. It's a function you can plug directly into other scikit-learn functions, like cross_val_score to evaluate your model. It's like getting a standardized, ready-to-use version of your scoring metric. This is false. Check_scoring doesn't automatically handle problems with multiple outputs. For that you would need to tell it how to handle the multiple outputs with an appropriate averaging strategy or a custom function. I'll explain the check_scoring function in scikit-learn. It's a crucial tool for verifying that the scoring metric you're using is valid and correctly formatted before you use it in model evaluation. Think of it as a quality control check for your scoring system. If you give check_scoring a scoring metric name that doesn't exist, let's say, accuracy_score_ incorrect, then check_scoring will correctly raise a value error to let you know there's a problem. It's like a helpful error message telling you to double check your spelling. The main job of check_scoring is to give you back a function, a callable scorer, that you can use directly with other scikit-learn functions such as cross_val_score . This allows you to seamlessly integrate your chosen scoring method into your model evaluation workflow. It's like getting a ready-to-use tool perfectly fitted for your evaluation task. This statement is wrong. Check_scoring is flexible enough to handle custom scoring functions, not just ones that are built into scikit-learn. As long as your custom function follows scikit-learn's rules for a scorer function, you're good to go. Think of it as accepting custom tools along with the standard ones. Incorrect. For problems with multiple outputs, check_scoring doesn't automatically handle things. You'll need to explicitly tell it how to deal with multiple outputs by specifying the right multi-output scoring strategy. It needs specific instructions, like a chef requiring a detailed recipe. This is the main quiz question regarding check_scoring function in scikit-learn. You need to identify which option correctly represents the functionality of the function. This is just a heading for the overall problem.